Hearing all the buzz about AI? Not sure how this is going to impact your job in the future? In this episode, I discussed the two ways AI is impacting network engineering: networking for AI and AI for networking. Curious to where all this is heading? Then keep listening.
Do you want a career in networking but aren't sure where to start? Are you struggling to take your career to the next level but aren't sure the path? Welcome to Cyber Job Hacks, the podcast that gives you the strategies you need to launch and grow a successful career in network engineering. Hosted by Dr. Jeff Colburn, a solutions architect with over 30 years of experience designing and implementing large-scale networks. Each episode is built around one of the three core pillars of becoming a next-level engineer: developing deep technical knowledge, applying design best practices, and understanding technology decisions. Let's get started.
Welcome. I'm your host, Jeff Colburn. In this episode, I want to talk about that elephant in the room, AI. Some of you are already using it. You're using Claude, using ChatGPT, might be using it on a daily basis. I know I am. You see data centers popping up everywhere. You hear about it in the news. Whether you know it or not, AI is touching some aspect of your life. So what does that mean for network engineering in the future? Don't worry, my security-minded friends. I'm going to have an upcoming episode talking about the security implications of AI. But right now in this episode, I want to talk about the impact of network engineering. And it's having an impact. Just look for this year, for 2026, the projected spend on AI infrastructure is $1 trillion. $1 trillion. That's phenomenal. $650 billion of that is just within the tech giants alone. And then already $130 billion has been spent. They're spending more money now building data centers than on office buildings. So that just shows you where companies are investing. Everything's going into AI. And you have developers. They're building large data centers and securing large energy contracts, and then they're leasing this space out to AI companies. It's like a shopping mall model for AI. They're leasing out space and power. They don't care which AI company comes in or goes, because if one folds, another one will come in and use the space, because energy is key. There's not enough energy. So if you have large data centers and you secure the energy for those data centers, then you're going to get customers. So that's what these developers, they're not even AI companies, they're just developers building out facilities. So again, just showing you where the investment is right now. It's just gangbusters into AI. And then just look at company direction right now. Like Cisco cited in the latest earnings call, a networking supercycle fueled by big tech AI data center build out. Right? They raised their 2026 target from $5 billion to $9 billion in revenue. And they're restructuring a company around AI and high growth technology. These guys announced a 4,000 person layoff and the stock still shot up. Right? It wasn't because they were doing bad, it's they're restructuring the company and investing in what they know as high growth areas. And look at Arista. Arista stock keeps climbing because they're one of the leading providers of AI infrastructure. So AI has become this main focus. So what does this mean for the network engineer? Well, there's a couple of terms you may have already heard. One is networking for AI, and the other is AI for networking. No, this is not some clever play on words. These are actually two distinct areas of focus. So let's start with networking for AI. Like any other application, AI needs a network infrastructure, right? GPUs need to be connected to each other, right? This is that back-end network. And then the AI clusters or GPU clusters, they need external connectivity. And this is that front-end network. Now, if you've heard of AI clusters or GPU clusters, you probably heard of NVIDIA, right? They dominate the GPU market. They sell the GPUs, and the majority of the time, they sell the back-end network. And the technology they use for that is called InfiniBand. Why InfiniBand? Well, GPUs use a protocol called Remote Direct Memory Access, or RDMA. And this is what permits the various systems to transfer data directly between memory locations. So for AI, this has to be done at high speeds, low latency, and really important, without loss. InfiniBand is not new. It's been around since the 2000s. However, it wasn't until NVIDIA acquired Mellanox in 2020 that it started playing a major role in AI build-out. So today, you hear about NVIDIA, you're going to hear about InfiniBand, because essentially they're the ones that are using InfiniBand for the back-end networks. However, our friend Ethernet is not going to go away. He's not giving up that easy. And to be honest, long-term, Ethernet will win out over InfiniBand. Ethernet always wins. I'm someone who came from the days of Token Ring, FDDI. Ethernet always wins out. It's like everyone knows Ethernet. Everyone keeps using Ethernet. It's easy. So I believe in just the way even recent trends now, Ethernet's going to win out InfiniBand. Ethernet's like BGP. We just keep adding things to it. We know it. We love it. We're just going to keep morphing it into what we need it to do. Same with BGP. We just keep adding address families for every new thing that comes out. Instead of we're not going to reinvent the wheel. We're just going to add to what we know and love. So that's Ethernet. So with Ethernet, you have something called RDMA over Converged Ethernet version 2, or Rocky V2. So unlike InfiniBand, that is a specialized networking fabric, Rocky V2 runs atop our two friends, Ethernet and IP network. Something everyone knows and loves. So no specialized switches, no specialized adapters, no specialized protocols. It's everything you already know. Ethernet switches, IP networking, UDP encapsulation, and standard optics. Now, when we're talking about Ethernet switches, we're talking about very fast Ethernet switches. We're going from 800 gig and now approaching 1.6 T. But it's not without its challenges. One of the challenges is equal cost multipath, or ECMP. ECMP load balances using flows. It performs a hash on a header, and it determines a path for each flow. And then ECMP will determine, based upon flow, which path to forward that frame. So ECMP wasn't designed for this type of traffic. So with Rocky V2, you could have this concept of an elephant flow. It's just the same flow of traffic across the same path. And, it's a very large flow, right? Because you got a lot of east-west traffic going on between these GPUs. And so we have this thing called an elephant flow, and it's going to cause latency. And what could be disastrous is buffer overflows. So what happens when a buffer overflows? We drop frames. Very bad for an AI cluster. We do not want to be dropping frames. So ECMP has a challenge. At the same time, as you could have this elephant flow going one path, you could have other paths that are underutilized, right? So ECMP is not ideal when it comes to a back-end network. So there's a lot of ongoing debate and technologies being deployed on how best address this issue. And you're going to hear things like adaptive load balancing, packet spraying, congestion-aware routing, explicit congestion notification, or ECNM, right? Everybody's trying to address this issue with ECMP. And recently, you had multipath reliable connection, or MRC, be announced, and that's utilizing SRv6. And then you have another emerging technology called Ultra Ethernet. So it's going to be some time before all this completely shakes out, but no one is waiting. They're building out like crazy. So there's a lot more I could share about networking for AI. I haven't even touched on the front-end network, but this gives you an idea of networking for AI. But what about AI for networking? This is using AI to help operate the network. This has been around for a bit, and it continues to get better. You had AI assist identifying issues, so the days of hunting for the cause of an issue are over. AI finds the problem before you even know there is one. We are still in the AI assist mode, so it's going to leave it to the human to decide how to fix it, but it's going to find it for you. But AI does more than that. So welcome to AIOps. So what does AIOps do? It goes beyond just detecting problems. It's going to correlate events. It's going to analyze telemetry data. It's going to predict failures, right? Now you start to get like Minority Report. It's going to tell you something's going to fail before it fails, right? It's doing predictions for you. And it's going to improve overall efficiency for your network. So what used to take us hours now takes minutes, if not seconds. So low-level tasks are going away. For someone that used to have to jump from routing table to identify an issue, some of this is welcomed. So that's networking for AI and AI for networking. Is it going to steal your job? Maybe. Depends on what you do. Will you need to adapt to what is coming? Of course. I've been in this industry for over 30 years, and you're always adapting. This is nothing new. What is important is knowing the proper skill sets for what is here and for what is coming. Now, will everyone be building out AI data centers? Not anytime soon. Traditional networks aren't going away, and it's certainly not going away that quickly. So what is most impactful now is the use of AI in network operations. That's impacting the entry-level ops engineers. So you're going to have to learn the tools used for AI ops. AI will be assisting you, or you will be assisting AI. Either way, you'll be working with AI. Now, if you find that you're just the physical hands for AI, that tells you don't want to stay at that level very long, right? That's the direction it's heading, where AI is basically taking all the role or all the work for the entry-level ops engineers, all that drilling through tables, going through logs. AI is doing that. You're not doing that anymore. So you're going to have to find something else to do because AI is doing that. You gotta grow your career. You got to move beyond ops because a lot of that low-level stuff is being done by AI. Now, for the network engineer, you still need to know your core technologies. Look at the front-end network. It's used in Ethernet, it's used in IP routing, and BGP. Some other things you probably want to add if you don't already know it, know spine leaf architecture, EVPN VXLAN. These are things you're going to want to get to know if you don't already know it. And if you plan to work on back-end networks, then it's RDMA, Rocky V2, and lossless Ethernet. You got to stay on top of the latest congestion management approaches. And you got to follow which technology or technologies that are being widely adopted. It's still very early in the game. So we don't know what's going to win out. Something will win out. It always does. But right now, it's a battle between approaches, and we're going to see which one wins out. So you got to stay on top of that. The good news for network engineers is there's still plenty of work outside building AI infrastructure. Right now, I recommend you learn how to automate workflows if you're still implementing networks. Companies may not be implementing AI infrastructure, but they are demanding that changes be made more quickly and they have less tolerance for human error. So start learning how to automate your workflows. For the design engineer, it's like I've been saying before. You have to know your core technologies and you have to know your design best practices. That's not changing. Technologies are changing. How you design with these new technologies are changing, but their approach is the same. Got to know the technologies, how to design with them, how to rationalize your design decisions. Design engineer, yeah, the same role, same responsibility, same skill set, just different technologies. So, just kind of wrap up this episode. AI is here, it's growing fast, but it hasn't taken over yet. Not everyone has become an AI data center architect, right? There's still plenty of campus, wide area, and there's still plenty of campus, wide area, and traditional data centers to be built. AI is more of a tool to be used right now, especially for the ops people. So get clear about what you want to do, align yourself between where you are and where you want to be, keep an eye on emerging technologies, and the ever-evolving skill sets required to do what you want to do. Now, keep in mind, when I started, we had IPX, we had DECnet, we had AppleTalk, we had Token Ring, Frame Relay, ATM. I could go on. The point is that the industry is constantly evolving. This is nothing new. You just have to evolve with it. So I hope you found this useful. Until next time, have a great week.
Thank you for listening to Cyberjob Hacks, the podcast for next-level engineers. If you found this episode helpful, be sure to follow the podcast so you don't miss future episodes on how to take your career to that next level.